I'm currently waiting for a few parts to turn up for some projects I'm working on, and before I start any new major projects there are a few small tasks I wanted to try and get out of the way. Now, if you've been watching my videos you might well recognise this. This is my Fluke 9010a. In fact, this is my spare Fluke 9010a. It's the one I've been using for the recent videos, and the reason I've got this one on the bench rather than my main unit is because I'm actually doing some work on this, and that's what I hope is going to be a short series of videos is about. Now, the observant of you may have noticed that there's something wrong with this unit. It's certainly been visible briefly in a couple of videos, but I'll just raise the camera and hopefully coming into view you can see what the issue is, and that is there's a big hole on the top, so the tape drive is not fitted. And the reason the tape drive is not fitted is because I have the tape drive here. So we'll move over to the bench and I'll explain why this isn't fitted to the machine. So I have the tape drive on the bench, and there are two reasons I remove this. The first is it doesn't work, so I need to get it repaired, and the second I'll come to in a few minutes. Now, this particular unit, this particular Fluke, doesn't have an RS232 card in it, so I need to use tapes to load and save programs. Now, while I will be duplicating and reproducing the RS232 card for these machines probably sometime later this year, I still want the tape drive to work. I still find them useful on occasion, and it saves me having to boot up the PC and get the PC connected to the Fluke, and having the programs on tape also gives me a good way of archiving them. The problem, as I'm sure that anyone that has one of these machines will know, is that tapes have got ridiculously expensive. I'm all for people making a profit, but once you go past a certain point then you're kind of pricing the use of the machines out of the market, and in fact you're pricing yourself out of the market as well, because people aren't going to be able to pay what you're demanding. And also it can be harmful to the machines themselves. If they become too expensive then people just won't bother repairing them, or they just can't afford to repair them. Currently I think there's a single tape on eBay for one of these for $150. I think that's a bit excessive, and as I say, while I'm all in favour of people making a profit, I do believe that in some areas it has become excessive and it is becoming a bit of an issue. So the second reason I wanted to have a look at this tape drive was to see if there's a way to re-engineer it to use a different type of tape. So firstly, the fault with this, there were several faults. Firstly, there was supposed to be O-rings on the outside of these, and they've just completely dissolved. They were just spread all around the inside of the tape drive, so I've spent some time cleaning this out. And for some reason, I don't know why, but there's a board that sits on the bottom of this. It was completely covered in, well, I thought it was oil, but it turned out to be kind of thick grease, and I wasn't quite sure why it was there. And it turned out that what somebody had done, for some reason I can't quite fathom, is underneath this particular wheel that sits on this post here, it had just been completely covered in thick grease. I don't really quite understand what the intention was there, but obviously it was stopping this thing working at all. But once I'd got it up to this point, it is now working, and it'll work with a standard tape. But as you can see, I've taken the drives off, and the reason I've done this is I want to see if it's possible to modify one of these drives to accept a more standard tape, that is a tape like this. So whereas the Fluke tapes are rare and expensive, you can get these tapes for just a few pounds each, and they're easy to get hold of, they're still being manufactured, and as I say, they're very cheap. And the main problem with them is they won't fit into the drive. Now they kind of will fit in, they will go in and this will close, but if you have the drive pulleys on, then they won't go in properly, because the spacing of these pillars is not exactly the same as the spacing on the tape. So the spools on the tape aren't the same as the Fluke drive, which is obviously a bit of a problem. So what I've been looking at is whether it's possible to modify this tape drive. There are two things I would need to do to make it work, and I've been looking at this fairly carefully. The first one is I would need to move these two pillars, these two support pillars, and the way that this drive's arranged, if I just get this out of the way, is if you take some measurements, then the existing post is too far out in this direction. If you imagine this is where the tape head would normally sit, so you have these two and they're both too far out in this direction to accept this type of tape. But doing some measurements, it turns out that if you take into account the diameter of these posts, then it is possible to drill another hole in a different location, and the geometry is such that it is possible just to drill a second hole without it crossing over into this hole. There's only 0.1 millimeters here, but it is still possible to move this and drill another hole and then press these into that hole. And luckily, if you look inside the drive, I don't know how clearly this will come out on camera, but the raised section that the existing support sits in is actually extended in the correct direction anyway. So I'm wondering if this drive was maybe designed with the possibility of using either tape type. So that's the first thing that needs to be done. Luckily the two guide pins are in the right place, so they don't need moving. But the other problem is the record and playback head is in the center position for the Fluke tapes. But with this type of tape, then you notice that in the middle there is a post, a support. So you've got this thing in the way, and on whatever machine these are meant to run on, obviously the head is meant to be in this location or this location. But again, looking at the drive, there's plenty of room to actually move the head across, so it needs to be moved across to put it approximately in the center of what is currently the gap, and there's plenty of room to do that. So the two modifications I would need to make are to move these two posts and to move the head across. Now of course the possible issue you could get there is whether or not the drive wheels can then still drive the tape. But again, looking at the geometry, we're only moving about 0.7 millimeters in any particular direction, and because of the way that this transport mechanism works, okay, now it works by moving this lever across, so it engages in one side or the other, but the throw of this and the position of it is sufficient that if I do move these, then it will still work. I'll just have to put a slightly different diameter O-ring, but only by about 0.2 millimeters, and it will then work fine. So what I intend to do is I'll strip it right down, take it out to the CNC mill, and I'll bore a couple of holes. I'll pull these pins out that is pressed in. I'll bore a couple of holes in what should be exactly the right position. So, okay, the correct location is actually to move the pin 1.2 millimeters this way and 1.2 millimeters this way. So that will give me the new location for the pin relative to the existing location, and then all I have to do is move the head across, and that just entails drilling and tapping a couple of new holes in this support plate, which should be fairly easy to do. All I'd have to do then is reassemble the drive and see if it works. Now there are a couple of issues that I've come across so far. I bought a few of these tapes off eBay, and some were second hand and they turned up and they're not usable. The seller was a bit less than honest, but this tape has been destroyed. It won't be usable in a machine, voice recording or a data machine like this. So you're best sticking to new ones. Having said that, you'll need to find a source that will provide the right sort of tape. Now these are, in theory, standard tapes, and I'll leave the model number for the tape in the description, but they do have a specific designation number. If you look at Philips micro cassette or mini cassette, you should be able to find these fairly easily. The problem is there are two different types that I've found. One is, ignore the fact there's no pillar in the centre on this one, I've taken that off. This was a new tape I bought. I think I got it off Amazon. But unfortunately this tape doesn't have the reflective leader on it. So when this is one right to the end, but you can see it's just bare tape. Whereas if I look at another tape I bought, this is another new one, you can see that on the end it's got a reflective leader, and that needs to be there for the Fluke to work. If we look inside the Fluke, you'll see this device down here, hopefully you can see that, and it's a sensor to detect the end of tape, or the start of tape depending on how you look at it, and that needs to be there to allow the Fluke to rewind and figure out where the start of the tape is, and also to see the end of the tape. So you do need to get a tape that has this reflective leader on it. Now of course you could, if you got the right equipment, splice in a reflective leader yourself. I still think that's possibly a good way to go in terms of getting the cost of these things down. So that's the plan of action. I don't know how feasible this will be. If it doesn't work, then I'm not destroying the tape drive. I can just put the pins back into the existing holes. As I say, I'm not destroying the hole. Another option I had here was to bore this out and put a brass bush in there that I could rotate with an offset hole in it, and the hole will be offset by half of this distance, and that would allow me to rotate the bush around 180 degrees to select either tape type. But to start with, I'm just going to see if it's possible to drill the hole offset. I think using a very sharp carbide drill, I should be able to drill the holes accurately enough and cleanly enough that they shouldn't, we shouldn't break into the existing hole. So as I say, that's the plan of action. I don't know how successful this will be, but if it works, then it will certainly be a much easier way for me to use this machine in the future. If it does work, I'll give some dimensions and possibly some drawings as to how I made the changes. If you do decide to try and strip one of these down, if you haven't done it before, be very careful. There are some very small parts in the tape drive, and they do need to go in specific places. They're fairly easy to get apart, but as I say, it's just a case of there are some very small parts in these. Okay, so that's step one complete. I've bored out the holes. As I say, I've moved them across. I actually went up and across by 1.1 millimeters on each side rather than 1.2. It seemed to be far closer to the actual centers of the cassettes. I've drilled these out to 1.5 millimeters. The pins are 1.6, so it should be a nice press fit. I'll get those pressed in and we'll see if they line up with the center of the cassette spools. Okay, so I've pressed the pins into the moulding. The centre of the spools on these cassettes is at 24 millimeters. So because they're 1.6 millimeter pins, if I measure on the outside of the two pins, I should be getting 25.6 if I've got them in the right place. So let's have a look at this and see how close we are, and 25.60, so that's looking quite promising. And in theory, if these are in the right place, then when I put a cassette on the pins, they should come up centrally through the two spools. And let's have a look. And indeed they do. They look fairly central. So what I'll do now is just temporarily refit the two pulleys and see if the cassette will fit onto the drive sprockets. And if they fit on cleanly and they don't bind, then that's a good sign that the cassette will turn freely, and we're on the right track to get these up and running. Okay, so I've just temporarily fitted the two drive sprockets. If I try putting a cassette onto these, then the sprockets should come up through the centre of the tape, and there should be a very slight play in all directions. It shouldn't be pushing itself towards one side. So as you can see, it's moving up and down by about the same amount each side, and left to right the same on each side and the same on both sprockets. It looks like they are exactly in the center of where they're supposed to be. And because the cassette is located on the 2 pins, we know the cassette's in the right place, so it looks like that will work fine. The only thing I need to do now is make sure that the actual drive will engage properly. So I'll refit some O-rings to the outside of the 2 drive wheels, see if they will then mesh with the actual drive pinion, and what I'll do then, if that all works, is I can start looking at relocating the read-write head. I've replaced the 2 O-rings that fit on the drive pulleys. I've tried to select O-ring sizes that give the correct size and width for the pulleys, and it is important that they are fairly close to the correct size because these dictate the speed that the tape runs at. Also, because I've moved the effective centres of the 2 cassette reels, we need to check that these will now correctly engage with the drive capstan. So the way this works is the capstan assembly sits on this post, and the solenoid that sits here rocks this assembly back and forth and engages the forward and reverse directions for the mechanism. So in one direction it will engage this pulley, and it should engage and turn it freely, and there should be enough clearance that when I fit this one they're not both engaged at the same time, but there should be a millimetre or so of play between them so it can sit either in the centre or it can engage one or the other. So if it's moved this way, for example, then the motor can turn the left hand of these 2 pulleys, and if it moves the other way it can turn the other pulley, which will drive the tape in the other direction. So that seems to be working fine. The next step is to determine how far to move the head across, so we can get these out of the way. So now that we have the drive sorted out, the next thing we have to do is decide how far and in which direction to move the read-write head. In the original configuration the head was in the centre of the tape, but we can't use that in these tapes because there's a support in the way. So we need to move it so that the head is sitting halfway between the centre support and one of these side supports. But in terms of which way we move it, if we look at the read-write head, we can see that it's a single-sided head, and with the mechanism in this orientation, then the active part of the head is towards the top as we're looking at it. If we then look at the tapes, we can see that the support pads for the tape are offset. As we look at the tape, the pad on this side is towards the top and the pad on this side is towards the bottom. So if we look back at the mechanism, we can see that with the tape this way up, then the pad on this side, which is here, will be towards the top. In other words, we need to move the head in this direction to make sure that the pad will hold the tape against the read-write head. If we move it the other way, then the active part of the head won't have anything pressing the tape against it. So in other words, we need to move the head in this direction, and it needs to move a distance that will place the center from the center point here to the center point here. So I can measure this, and that's how far across I need to move the head in this direction. So I need to move it so it's about here, but I'll measure that. I'll drill and tap a couple of holes, and then I can have the head in the right place. And then once I've done that, we can start reassembly and see if it's going to work. Okay, so what I've done here is drill and tap 2 new holes. I've moved the holes 6.5 millimeters across, which is the distance I determined would put the head in the center of the open space in the tape. I've also moved the adjusting screw. There's an adjusting screw here that's used to set the height of the head to make sure that the tape and the head align correctly. So that's just an M2 grub screw. So it's just an adjuster screw here, and it's used to set how high the head is in relation to this plate, and that is used to position it in the center part of the tape. So what I'll do now is get this all reassembled. There is still another issue I've noticed. It doesn't use a reflective sensor. I thought it used a reflective sensor to detect the end of tape, but looking at the two sensors, it looks like it's a clear leader it's looking for. So it may still cause us a problem there. I should stress here that nothing I'm doing is irreversible, so if I need to, if this doesn't work, I can always revert the drive back to the original form. Okay, so I've got the head mounted back on the plate. I've got the plate mounted back in the carrier. Everything seems to line up, so looking at the back, I had to relocate the grounding strap, but it all seems to fit. It's lined up, nothing's binding. This is the screw that's used to adjust the height of the head relative to the tape, so I'll adjust that once the whole thing's been reassembled. But if I try just sliding a tape in, you'll see that the head fits nicely right in the center of the available gap, and the tape goes into the groove in the head. So it looks good so far. It's all lining up the way I wanted it to, nothing's catching. Okay, so the next step is to get this reassembled onto the chassis and see if I can remember how it all goes together, and then I'll be able to adjust the head height, and hopefully it'll be ready then to give a test. I don't think it'll work straight away. I'll have to figure something out with the end of tape sensor, but at least we'll be able to see if the Fluke is capable of reading and writing the tape. So I've reassembled the drive. It's all gone back together reasonably well. It all seems to line up. The solenoid works. It's got the correct amount of throw to engage and disengage the two spool drives. The head lines up properly with the tape, and if I put a tape in and then try and close the door, you can see it closes nicely. There's no binding, and it seems to fit. The head lines up perfectly. You probably can't see it, but it does go straight into the slot on the tape. The tape does drive if I try manually holding the solenoid and turning the motor. So the next step is to try it in the Fluke. As I said, the only issue now is the end of tape detection. What I might try doing is just splicing a clear section into the end of the tape. But that'd be a small price to pay to have to do that with each tape, considering the current cost of these tapes. And I do use the tapes for kind of archiving, and very convenient if I'm doing specific testing on a particular piece of equipment. I don't need to keep hooking up the RS232 and booting up the PC every time I want to run a test. With the tape, of course, I can just store the programs directly on the tape, and then each time I want to use it, I can just pop the tape in, load the program, and it's ready to go. Everything seems to line up. The only thing that doesn't line up, of course, are the holes in the cover plate. The spool drives are no longer central in that plate because, of course, they're now closer together, but there's plenty of clearance. They don't bind or drag on the edges. The tape detection plunge is working, so everything's in place. I'll pop it into the Fluke, and in the next video we'll see if it works.